In this lesson, I'm going to show you how to evaluate a limit using a table or a graph. So let's get right into it by looking at an example. So remember, when we are finding limits, we always look at how our limiting value is approaching from the left and from the right. So if I'm looking at this function f of x, as I'm approaching the value of 6, which I'm looking at the limit of as x approaches 6 from the left, we see that the function values are getting closer and closer and closer to 62. When I am looking at as x is getting really close to 6 from the right, as I see in the second part of this table here, we notice how, again, the function value is getting closer and closer and closer to 62. So since the limit from the left and the limit from the right are both approaching 62, I could say that the limit as x is approaching 6 of f of x is 62. In this next example, I'm looking at the limit as x is approaching 0 of this function. So again, I'm looking at my limit from the left in this first table and my limit from the right in the second table. So as I'm getting closer and closer and closer to 0 from the left, I notice how f of x is getting larger and larger and larger and larger. So it's looking like as x gets closer to 0, f of x is going off to infinity. Now, as x is getting closer to 0 from the right side, again, I notice how f is getting closer and closer and closer to infinity. It's getting larger and larger and growing without bound. So we could say the limit as x is approaching 0 from the left and the limit as x is approaching 0 from the right is equal to the limit as x is approaching 0, which is infinity. My last example here with a table showing this numerically is showing what is the limit as x is approaching 3 of this function. So again, as I'm getting closer to 3 from the left, I'm getting closer and closer to what looks like negative infinity. As I'm approaching 3 from the right, however, it looks like I'm getting closer and closer to positive infinity. Well, the limit from the left is not equal to the limit from the right, so the limit here doesn't exist. Now let's look at some examples where we're finding the limit using the graph. So here I'm looking at the limit as x is approaching negative 3 from the left, from the right, and we're going to see if there is a limit, because if they're the same value, then I could say that what the limit is. So here I am at negative 3. It looks like as I'm approaching negative 3 from the left, I'm getting closer and closer to a function value of 2. As I'm approaching negative 3 from the right, I'm also approaching that value of negative 2. So I could say that the limit as x is approaching negative 3 is equal to 2. Now let's take a look at what the limit is as x is approaching 5. So I'm not going to go through looking at the left and the right because I should automatically be doing that. So as I'm approaching 5, so here's 5, I see that there's an asymptote here. As I'm approaching 5 from the left, I'm going towards negative infinity. As I'm approaching 5 from the right, I'm going to positive infinity. So similar to that last numerical example we had, since the limit from the left is not equal to the limit from the right, my limit here does not exist as x is approaching 5. Here we have a graph that has a hole in it. So let's take a look at what's happening as x is approaching a value that has a hole in there. So I'm looking at as x is approaching negative 2. What is the limit of my function? So again, I'm looking at from the left and from the right. So as x is approaching negative 2 from the left, my function is approaching positive 4. I'm not equal to it. I don't have to be equal to it. If you remember what a limit is, it's what my function values are getting closer to as x is approaching that value. Now, as x is approaching negative 2 from the right, again, I am approaching that function value of 4. So since the limit from the left and the right are equal, we could say that the limit of f of x as x is approaching -2 is equal to 4. So a little summary of our limits. Well, if the limit from the left is not equal to the limit from the right, we can flat out say the limit does not exist. And that's true whether we're looking at the graph or looking at the table. If the limit from the left is equal to infinity, and that could be plus or minus, but the limit as x is approaching a from the right is equal to, again, the other type of infinity, either positive or negative, again, they're not equal. So kind of a reiteration of the first criteria I have here, they're not equal, so the limit doesn't exist. Lastly, if both the left and the right-hand limits are tending to infinity, as long as it's the same type of infinity, meaning it's either both positive or both negative, we could say that the limit is infinite.